One small step, one giant leap of doubt. On July 20th, 1969, the world watched in awe as Neil Armstrong took his first steps on the moon. A monumental achievement, a giant leap for humanity. Yet, even as we celebrate this triumph, a shadow of doubt lingers. Some believe the Apollo 11 moon landing was faked, a grand hoax staged in a Hollywood studio. Could this be true? Did we really land on the moon? Seeds of distrust, the birth of a conspiracy. The moon landing conspiracy theories emerged soon after the event itself. Fueled by Cold War tensions, distrust in government, and a lack of understanding of basic science, these theories took root in the fertile ground of skepticism. Books, documentaries, and websites emerged dedicated to exposing the truth behind the alleged hoax. These theories, despite lacking credible evidence, continue to circulate, chipping away at the legacy of one of humanity's greatest achievements. Stage lights or sunlight, debunking the Hollywood set. One of the most persistent claims is that the moon landing was filmed on a Hollywood soundstage. Conspiracy theorists point to the artificial look of the lunar landscape, the shadows in the photographs, and the waving flag as evidence. However, these claims crumble under scientific scrutiny. The unique lighting conditions on the moon, the properties of lunar dust, and the mechanics of flagpoles in a vacuum can easily explain these observations. The consistency between images taken by different Apollo missions, and more recently, by lunar probes from other nations, further debunks the Hollywood set theory. The moon is real, and we have the pictures to prove it. A cosmic obstacle course. Navigating the Van Allen belts is a critical challenge for space missions. Another popular claim revolves around the Van Allen radiation belts, which are two zones of intense radiation surrounding Earth. These belts are formed by charged particles trapped by Earth's magnetic field. Conspiracy theorists argue that humans could not have survived the journey through these belts without fatal radiation poisoning. However, they overlook the fact that NASA meticulously planned the Apollo missions to minimize exposure. The engineers and scientists at NASA calculated the spacecraft's trajectory, speed, and shielding to mitigate the risks. The spacecraft were designed to pass through the thinnest parts of the belts quickly, reducing the time astronauts were exposed to high radiation levels. Furthermore, the astronauts wore dosimeters, devices that measure radiation exposure. These dosimeters provided real-time data on radiation levels, and the data collected showed that their total radiation dose was within acceptable limits. The radiation levels were carefully monitored and analyzed, and were found to be comparable to the levels experienced by astronauts on the International Space Station today. The Van Allen belts, while dangerous, posed no insurmountable barrier to the Apollo missions. The success of these missions demonstrated that with careful planning and advanced technology, humanity could overcome the challenges posed by space radiation. Starry, starry night, or not? Addressing the missing stars. Where are the stars? This question has puzzled many and fueled numerous conspiracy theories over the years. This question is a common refrain among moon landing deniers. They argue that the absence of stars in the Apollo mission photographs is a clear indication that the landings were staged. They point to the lack of stars in the photographs and videos as evidence that the landings were faked. But is this really the smoking gun they claim it to be? However, this argument betrays a fundamental misunderstanding of photography. To understand why stars are missing, we need to delve into the basics of how cameras work. Capturing both bright objects like the lunar surface and astronauts in their sunlit spacesuits, and faint objects like stars in the same image requires different exposure settings. When a camera is set to capture bright objects, it often cannot pick up the faint light from stars. The Apollo astronauts were primarily photographing their activities on the moon's surface, which was brightly illuminated by the sun. The harsh sunlight reflecting off the moon's surface and the astronauts' white suits required specific camera settings. The cameras were set to capture these bright objects, resulting in the stars being too faint to appear in the photographs. This is a common issue in photography, not a sign of deception. It's like trying to photograph stars in a brightly lit city. The city lights drown out the faint light from the stars. The same principle applies to the moon photographs. The absence of stars in the Apollo photographs is not evidence of a hoax, but rather a consequence of the lighting conditions and camera settings. Experts in photography and space exploration have repeatedly explained this phenomenon. The cameras used during the Apollo missions were meticulously designed and tested to handle the extreme conditions of space. They were optimized to capture the astronauts' activities and the lunar landscape, not the distant stars. Modern astrophotography often uses long exposure times to capture the faint light of stars. This technique was not practical for the Apollo missions, where quick, clear shots of the astronauts and their surroundings were the priority. Different space missions have different photographic goals and conditions. The absence of stars in some photos is a technical result, not a cover-up. Understanding the science behind photography helps demystify these images. So the next time someone questions the authenticity of the moon landings based on the missing stars, remember the role of camera settings and lighting conditions. The stars are still there, just not captured in those iconic images. Shadows of doubt, unmasking the shadow anomalies. Some conspiracy theorists highlight apparent inconsistencies in the shadows cast by objects in the Apollo photographs. They argue that these shadow anomalies indicate multiple light sources, suggesting a studio setting. However, these claims are easily debunked with a basic understanding of perspective and the properties of light. Parallel lines often appear to converge in the distance, a phenomenon known as perspective. This effect can make shadows appear non-parallel, even when the light source is distant and singular, like the sun. Additionally, the uneven lunar surface can create further distortions in shadow angles. The shadow anomalies are not anomalies at all, but rather completely explicable optical illusions. The persistence of doubt. Why conspiracy theories endure. Despite overwhelming evidence to the contrary, moon landing conspiracy theories persist. Why? The reasons are complex and multifaceted. For some, it's easier to believe in a grand conspiracy than to accept the reality of such an astounding human achievement. Others latch onto these theories out of a distrust of authority or a desire to feel like they possess secret knowledge. The internet and social media have also played a significant role in spreading misinformation. Conspiracy theories can spread like wildfire online, amplified by echo chambers and confirmation bias. Once someone has bought into a conspiracy theory, it can be incredibly difficult to change their mind, even when presented with overwhelming evidence. Education and critical thinking are key to combating these beliefs. Encouraging individuals to seek out credible sources and question the validity of information can help create a more informed and skeptical public. Ultimately, understanding why conspiracy theories endure can help us address the root causes and foster a more rational society. Celebrating human ingenuity, the legacy of the Apollo missions. The Apollo missions stand as a testament to human ingenuity, perseverance, and the power of scientific exploration. These missions pushed the boundaries of human knowledge and capability, inspiring generations of scientists, engineers, and dreamers. The legacy of Apollo extends far beyond the moon. It ignited technological advancements, fostered international collaboration, and deepened our understanding of our place in the cosmos. Beyond the moon, the future of space exploration. Today we stand on the cusp of a new era of space exploration. With plans for lunar outposts, missions to Mars, and telescopes peering deeper into the universe, the spirit of Apollo lives on. The challenges are immense, but so are the potential rewards. By embracing scientific inquiry, fostering international cooperation, and nurturing the next generation of explorers, we can continue to push the boundaries of human achievement and unlock the mysteries of the cosmos.